Our third lecture video on fluids will cover the hydraulic principle. The hydraulic principle, or Pascal's principle, tells us that the pressure change at any point in an enclosed, incompressible fluid is transmitted throughout the entire fluid. Basically, this means that the pressure is constant throughout an enclosed, incompressible fluid. This pressure is transmitted without a measurable loss in all directions, up, down, and sideways. We know from before that pressure is a force divided by an area. However, if the pressure is constant in the system, we can compare the force per area at the input piston versus the force per area at the output piston. In other words, we can say that force in divided by area in equals force out divided by area out. Or force 1 divided by area 1 equals force 2 divided by area 2. This gives us a proportion which we can solve using the cross multiply and divide method, which we will go through in an example. Again, the pressure is the same on the large piston and the small piston. The total force on the large piston will be greater because it has a larger surface area as compared to the total force on the smaller piston, which will be smaller because it has a smaller surface area. Hydraulics are used as a simple machine to multiply an input force. Let's take a look at a four-part example. Find P1, P2, F2, and the mechanical advantage given the hydraulic cylinder shown. In this cylinder, we see that F1 is 22.0 pounds, which we can record in our data. A1 is 4.00 square inches, and A2 is 95.0 square inches. We need to find P1, F2, P2, and the mechanical advantage, MA. We are going to focus on P1 first. The basic equation to find pressure is that pressure equals the force divided by an area. Since this is also our working equation, we can go right to the substitution step. Pressure is equal to 22.0 pounds divided by 4.00 square inches. This gives us a pressure P1 of 5.50 pounds per square inch. Since Pascal's principle tells us that the pressure in an enclosed, incompressible fluid remains constant, the pressure in this hydraulic cylinder is also constant. Therefore, P2 equals P1, which is 5.50 pounds per square inch. The next thing we need to find is F2. The basic equation we will use to find F2 relates the force per area on each cylinder. Force 1 divided by area 1 equals force 2 divided by area 2. We will directly substitute into this proportion. Since there is only going to be one unknown, we can cross multiply and divide to solve for our remaining value. We have 22.0 pounds divided by 4.00 square inches is equal to F2 divided by 95.0 square inches. We will multiply on the diagonal 22.0 pounds times 95.0 square inches, and then divide by what's left over, which is 4.00 square inches, to get an F2 of 523 pounds. The last thing we need to find in this example is the mechanical advantage. The mechanical advantage is always the load force, or F sub R, divided by the effort force, or F sub E. The mechanical advantage is basically how many times the input or effort force is multiplied to move a load or resistance force. In this problem, we can substitute in 523 pounds for the load or resistance force and divide that by the 22.0 pounds of effort force. This gives us a mechanical advantage of 23.8. This means that the input force we apply is multiplied 23.8 times to move a load that is 23.8 times our input force. Mechanical advantage also does not have any units. It is just a number. This concludes our discussion on Pascal's principle.